Guys, this is another OptiNews, and this time I have a lot of exciting things. I will start first with the less exciting things, because there are more than that. Even the less exciting things are cool. I made a video at a later time after my OptiNews, where I was showing my flip layer for 3DO, and there are some improvements with that, and I was showing this was a very slow version where I would copy the entire frame. This was a version where I will change only the pixels that are changed. There was an issue because the flea was using 256 color palette, which doesn't exist. The max color indices in 3DO in some texture modes are 32. So if there were palette changes, which they don't exist on this animation except at startup, if there were palette changes, I would have to update the whole VGA frame all the time. Read the pixel bytes, look at the palette lookup table, which values has changed, and render the entire set of 64,000 pixels. So for color cycling animation, the frame rate was much worse, like this, like 7 frames per second. Which is not bad for this animation, of course, but maybe in other cases it would be better. But after that video, I did some more improvements. One improvement was to this full frame update to write it in assembly. And I'm trying to do a lot of pixels at once with LDMI. I read a lot of sequential words in memory in the VGA buffer, and then extract the pixels, and then do the palette mapping, or then back, combine the pixels, write them back with HDMI, and I even unrolled that one. I did things as fast as possible, and we might see here how much it has improved the particular animation from 5 frames per second. I'm going to run Phoenix as always. Let's see the speed. No overclocking, full cell cycles. And here it is from 7 frames per second, 18 frames per second, which is, it's not 25 or 50, but a lot of these flea animations don't need to run so fast. And but finally I can fully do color cycling in the flea animation that needed, even re-rendering the whole frame every time, instead of the pixel that just changed, much faster. Fast enough to be okay. Because this flea animation have a speed limiter, which I haven't implemented yet. Some animation go much faster than they should. And the thing is, let's put this one. I might have done a lot of improvements on the flea animation. Someone told me, and I should have known that. And I mean, it's true that I use 16 point at some point because some data from the flea had to be read in 16 bits. And of course you can read a full integer and work on 2 values at once. I think like here. Or some other. But anyway, I did a lot of changes to avoid as much as possible to using short numbers, because that particular ARM chip on the 3DO doesn't have a load 16-bit number, store and load. It has a load word, of course, 32-bit, and store word, and it has a load B, load byte. And this is, yeah, oh no, not this. This is the 4DO version. Okay, this is, forget about this. This is overclocked. Let's see actual speed. And 4DO, I'm just used to debug on 4DO because I just click it and it opens and it's there. Here I have to press this button, and anyway, that's the real speed. 32 to 35. Even that is better. Even those animations that are based on previous pixels, because I think it was 28 to 30. So there's some improvement on the other animations too. And here is the thing now. So far, I could only load small animations. I could not load the robot track, which we will load now. But I did just to see it. I did a crude thing, which is to stream from the CD, but I'm not streaming properly. I'm just streaming in some big chunks every few frames. Whenever I need the next data, I'm streaming. This can be improved. I would have a buffer and maybe some thread that reads in smaller chunks and is trying to work parallel with the player without being too much burden on the CPU. But this is the naive way. It's not perfect. And in my free load, I have a new boolean. Let's see. Preload. Previously it was true. If it's true, it's going to load the entire thing in memory. But the big fleas will not fit in the small 3D memory. So if it's not preload, it's going to do streaming. I have a next block size. How much is that? Stream block size. So I should do that more variable maybe. I don't know how I do it now. Don't remember. Oh wait, no. I just don't remember. Oh, that's a bit big. But that's okay. Maybe I change it later. This is big because the first frame usually is the whole VGA screen. That it needs 64K usually to fit. But now I kinda improve it. I start with that. I need to see. I might have made some changes at some point where I would stream every frame individual. So I stream small frames. But this is variable. In the future, I should stream like, I don't know, 256 byte or 1K or 2K frequently. I should find the sweet spots and sometimes feed 3 frames, sometimes if there is more needed. Maybe have a buffer to synchronize. But we are going to see how the full the robot track, how does it work here? And I'm going to show you. Okay, it works. Freeze. You see there are some it's not bad, but there are some freezes when it's needed. This go too fast. So the frame goes from too fast to sudden freezes. Here that a lot of pixels are changed. Maybe a lot of data needed. When it does this transition, the crossfade. And you can even see that if I put no limits to the CD-ROM, this is going too fast, very few pixel change. Let's see now. It still slows down a bit, but because of the pixel changes. I haven't tried this. I have tried it on the 3DO, we will see it. But with the ODE, actually, I'm not sure if I tried with the ODE. I tried with and on another 3DO I have the Mnemos ODE, not the new ODE. I have the new ODE too. But anyway, you see, it's possible to stream stuff. Be improved, but okay, I'm going to show you a silly thing now. I'm gonna show you more. I'm gonna show you the overkill. So I managed to run the flea animation. You will see it. You will see it. I actually ran 3 flea animations, but of course, because they have to stream, it's going to be very slow on the 3D engine. Yeah, sometimes you know when things are streaming. When it does the crossfade. Here, this animation, now, this is a lot of changes. That animation makes it slow. So I'm running the flea. 3 big flea animation, streaming from the CD. I know there are better methods to do that. And I wouldn't need normally to run 3 animation on the 3D scene. So this is my 3D engine I was working. And I'm making some more exciting things with the 3D engine, which comes next. And now, so maybe see, I'm loading 3 animations. They are all for no preload. If you preload in memory, it's gonna crash because it doesn't fit. But I used to have an example. This one, everything is preload because these are small animations. I might try to run 1 or 2 of these on the real 3DO. So these are just playing. It's still playing 3 animations, so the frame rate is what it is. And they are mapped behind, and they are flipped. The texture is flipped. I could have put something else in the other side, but yeah, it's fun. So no CD streaming for those. And maybe we will see it on the real 3DO. So let's run a bit on the real 3DO. I think I have those flea stuff here. That's the best. Let's see how the robot rack. This is the one with the big 64K chunks. This is the one that streams smaller, whatever is needed every frame. Let's see how it's on the ODE. Here, of course, it streams bigger stuff. But it works. Those animations don't need a lot of frames, as I see. Even the original will throttle down the speed a lot. Let's see another one. Okay. Is the 1 3 big 3? Is this that everything streams or nothing streams? I don't remember. Okay, this is where everything streams. Yeah, invariable frame rate. I can't even control it. But it works. Three animations are streaming. Isn't that funny? Oh, the polygon there. Ooh, let's see that. Can you get it? Ah, I missed it. Yeah, oh there, I got it. Yeah, something off went with the polygon, with the cell render. Very high values. So, could it be this one that there is no streaming? Yeah, all three small animations. This is without streaming. Yeah, very big polygons have to be subdivided for this not to happen. And this, I'm playing three animations on the real 3D. The speed is not much different than the Phoenix emulator. And that's it. This is the first part of this OptiNews video, because the most exciting thing comes now. And I might try something. The next thing I want to show you, I haven't tried it on the real 3D. And I don't know how it will perform. But here we go. And here is the exciting thing. Few days ago I finally started working on my 3D engine again. The Bizarro engine, what I call the Bizarro engine. And it's the one I have showed you before, but I wanted to make a world renderer based on a 3D grid. And I had that in my mind, and then I have also seen someone discussing about the possibility of Minecraft or a Minecraft-like game on 3DO, and it was before that I started thinking about it, and I started experimenting with very basic things, trying to make things work. Here you have polygons that break, it doesn't work. I started with a very small grid and trying to create a static geometry, which I'm still in that stage. I want to change my engine in a more dynamic engine where the view pyramid will sample the cubes that has to render and will discard everything. Now I have an array of cubes and I would render them. This is wrong because these are the bugs. I was trying to do something and it's buggy. And now finally those were the very first steps. I had a cube made of grids. Here is where it started to get more interesting. I have a room full of different textures. Every cube has its own texture. This is where it starts forming. Okay, this is again things breaking apart the polygons. Here I try, this is why I still have to, I'm gonna show you the present form of the engine, which is more exciting, and I'm going to try to run it on the real 3D. But this is the early examples. I wanted to see if I can combine a model. And you have the grid world, which is a big mess, pre-generated mess. You have the teapot, but look what happens. Yeah, I need to solve the visibility problem. If I want to add entities that are not part of the world mesh, they have to be occluded. And this is my next plan. But for now, I would do some funny things like that. Rotate the whole map. And I started doing collision detection. You see, I continue building some more lifelike environments with the boxes, but everything is cubes for now. Also, I can combine this grid to have some slopes and other stuff, but still somehow do the collision. Oh, there was a bug there. I have bugs with the polygons. So I gradually started doing crazier thing, like a very big, very slow, very big Minecraft sphere. See the numbers here are 4,000, over 4,000 vertices and polygons. These are the quads, 4,191. These are the quads, and the memory is almost dead in this one. I was showing some pseudo, this is just a texture to show the wireframe, the amount of quads this thing had. So I definitely need to make some visibility algorithm. Although when you are watching the whole world, still has to render everything, but if you are somewhere closer, I should be able to only transform and rotate the much fewer dots and vertices that I need that will be visible. And here are the, if I render everything with dots. So it's an excessive amount for the 3D, and you don't normally need. So there is some kind of progress. I was changing, here is where I started to change the shading, abusing the PIXC value on the each cell polygon, which can make a full texture darker or brighter. But I was doing random because I wanted to add shading. Here is where I was trying to make everything blended. Again, a feature of the 3D. But all these are on emulator. So I don't know how this will run on the real 3D. It could be much slower because the blending is not for free. So I continue doing that, and I started doing some kind of pseudo, based on the nearby and the outside blocks, I could kinda shade parts that are receiving less light from the outside. I was kinda, this is still in progress. I added jumping. I'm showing this, but I'm going to show you, I just want to show you the progress, that I'm building something new here, that I will optimize more and even change the visibility algorithms a bit in hope to be able to do something practical. If you use few polygons, this scene is using 1300 vertices and 1003 0.6 polygons. If you do small scenes, there is some frame rate. And we will see on the real 3DO. I never ran those on the real 3DO yet. So I hope things are not much slower for this presentation. And finally here, I started using this magicavoxel tool, which it was the first thing that came in my search when I searched for voxelator, because I thought previously all those rooms I was doing them procedurally generated. It was a bit tedious to design things. I was calling draw box from this voxel to that, draw sphere, cut with sphere, cut with box to do these corridors. But now, as you can see, the thing I'm playing, I could do stuff in this magicavoxel and then load them. It's time to try our luck, because I never ran this and I don't know what to expect. I have tested in emulator so far, but it's time. I have put a lot of tests. Maybe the original world I was building with boxes and spheres procedurally in the code. The rest are things I either loaded or did on magicavoxel. So let's see how the original works. And this is the one with the big sphere. Not the big sphere, the kinda smaller. Okay. It's not worse than Phoenix emulator. See, when I look away, because the polygons are not in the visible, the pyramid view, you know, the frustum. At least I don't send them to the cell, but there are 2141 vertices, which I have to transform so that I know if they are inside or outside the camera. So I'm looking at the stars and just 13 frames per second. It's not 50, because the world is still transformed. If I improve my visibility, this will change. So this is the world. Maybe it's a bit slower than Phoenix, but I was expecting worse. And see, this is the one where the first one I was trying to do some pre-baked lighting. And I was doing a crude method where since this is in a block grid array, from every block I might throw some, I might walk into the voxel array through certain direction so that I see from the wall far away from its wall quad, and see if they hit other stuff, if they go outside in the sky. So if they go outside in the sky, those one will accumulate more light. That's why some parts are brighter, some parts are. But it's very crude the way I do, and it can be improved. Now, because that corridor would be dark, I also added an extra voxel array where you define some light maps. And it's like volumetric lights, really. So this also take part as I traverse the voxel to see how to light every block. They also accumulate. It's even better, actually. So that's the world, and that's the slower world, because I added the sphere. But you know, it's forming. It's slow now, but it will improve. And in the worst case scenario, I will design worlds that are not so heavy. I mean, this sphere. Why do you need this sphere? Also, I have the ninja mode here, where if I jump, it collides with the ceiling. But if I keep it pressed, it's like it's grabbing. But this is because of oversight in my jump gravity algorithm. So if I keep pressing A button on the joypad. If I leave, it will fall, but if I keep pressing it, it will jump like a ninja. And now see, this side everything is bright because it's outside, and the vectors I sent through various directions for each block, they always go outside and hit the sky. So it's like, okay, I will make this. Even if it's night, it should be, should still be. But yeah, I mean, you get what I mean. I didn't want to fall here. Now you see, I have collision. I didn't used to. And you see, there are some issues when I go very close. So there are issues I have to solve with the polygons. And the solution is because the polygons are very close to Z, and the calculation division, the projection by Z goes too far and overflows some number, or maybe if they are too close, I hide the polygons. So there are issues that I have to solve, and I might have to subdivide the closer polygon further. And see, now this corner has a bit more ambient shading, because there are nearby quads that some of the rays hit the floor up there. So the corner might look more ambient sometimes. But it's a bit round. I will improve the lighting, the pre-baked lighting. But it does the work now. It roughly does the work. It has some strange patches that don't make sense. Let's check the rest. Maybe the next one. Okay, let's go with this one. This is going to be much slower. I did some very crude example. You might see this seems very simple to be slow, but I made the whole box, 32 by 32 by 16. I'm inside a big box. It's like 3,000 polygons. Because you don't see much detail, you think why six sides of the cube are so slow? They are so slow because they are made of little cubes. But it's just an extreme example to see, okay, this is the maximum size of the current world. And there are some black things in the distance. Some of the polygons are not. And you see the lighting also tries to do something here, even if there is no outside source. The corners might be more... I don't know why the corner high is more bright, because I don't have a light source there. But maybe a vector goes outside by mistake. So that's a crash test only, okay. Let's go the rest. And I'll show you World 3. You will see something that looks more complex, because it's not just flat walls. I will show you that. You might think, how is this faster? Has much fewer. It seems more complex, but has much fewer. This is a model I got from the... That was a model of course the textures are wrong. They are a bit random, sort of. Because I can match the original model was a model of a 3D character, a warrior girl actually. And this, you might see more complex cubes there. Wait, the movement is kinda. But because they are fewer, more contained, It seems more complex, but it's only 700. It's the lightest one, but it's really Minecrafty. You could have a tiny Minecraft in this console. And it's 700. 700 vertices, 725 polygons. So some of these are characters I loaded directly. So when you look away, it's faster, but the model is still rotated. It's just that the polygons are not sent. When you look at it, these polygons are sent to the cell. When you look too close, only few polygons are sent. So there is a partial culling. If you look here, for example, the ones below, but also the ones on the left and right side that are not on the screen are not shown. But I still have to rotate the whole model vertices, as I said, to know what to finally render, which I will try with visibility algorithms to avoid. There's a lot of potential for this engine. So maybe let's check, since I started with World 3, let's check I'll go with World 1 because that was the one I started. This is a much slower one. Oh, hold on. Okay, I think I broke it. I'm stuck in a voxel, the gravity doesn't work. Okay. Or does it? I hope I can fall down. Ah, at least I fell down. Okay. What? Where am I? Sorry about that. I think I prepared all these tests, but I have positioned the player in different place. Okay, here we are. And I thought it was okay when I was testing it. This is the big central area. Oh my god, it's very slow. Maybe even slower. There are a lot of things. All these quads are using a 32 by 32 texture. For the far away, I could do some loading with the text. There is a lot of things. These are only a preliminary preview. Okay, it will improve. So I was scribbling and trying to... Where is the... It's too dark even. Sorry about that, I wasn't expecting this. I was doing corridors to try, moving in corridors. You go here. 2800 vertices, 2715 quads. Now, the number of quads are not the number of quads that are rendered. They are the number of quads that are modeled. But if I look there, very few quads are rendered, are sent to the cell. So it's not representative of what's rendered. But the 12,800 vertices, they always have to rotate it and transform. And then I decide if I will finally what is inside the camera view, what is outside, so that I don't render everything. Ah, there is this upper view. Ah, no, those are the stairs. I think I like this opening here, how the light goes brighter. All this light, as I said, is calculated automatically. You throw a model and it tries to see which blocks are more occluded, which blocks are getting the light from outside, and so on. If you see some empty blocks here for example, this side here seems empty. It's because it happens to touch the edge of the volume cube, of the volume array, and my check for nearby empty blocks and surfaces would fail the way I do it. Anyway, that was a bit bad. Let's go to the more exciting one. Okay, let's see. World 3, 2. This is a bit better. And it's a model I got from the software. A demo model, the head of a castle. And this is a castle, man. This is a castle made of cubes and the lighting is kinda nice. Kinda. That's the castle, man. So this again has 2700. But the frame rate, maybe it's the same. Let's see. Oh, I got on the sides. Oh, I dropped wrong button. So that's the castle. It's pretty complex again for the 3D. My plan is, if I cannot get the speed I want, I might design simple games with that. You can do some smaller mazes, for example, or individual rooms where if you enter a door, the screen fades away and it loads the next door, the next room. Kinda like Alone in the Dark or Resident Evil. But I think I would be able to improve things a bit. And it is impressive. Even such a world. It's not playable, but it's impressive for the machine, I think. I impressed myself. And let's see very fast the torus. This is an item from the, this is a demo item from the, actually there is a procedural generator in the software that you can do toruses and fractals and other stuff. There is one that makes a voxelized Mandelblob or a Menzer sponge. I think there is some kind of shader language in the magicavoxel. And they had this torus. Again, 2700 are too much for the 1000 polygons at most usual to get 15 frames per second. Which is not few. If you are efficient with a model, you can do some cool stuff. Torus. Okay, I might show you. I will go with the temple. This is a simpler scene I made. I wanted to see the lighting behind some. You will see. Still 2000. I need to do smaller structures to get. I have the nice grass there. So I tried to make this temple and put these pillars because I wanted to see how the light will propagate with the pillar. As I said, after I load the area, my own code will check if some pillars are occluded by other nearby voxels. If some blocks, some voxels are occluded. So it will make some crude calculation of the shadows, and it's not always right. It's weird. It has some weird boxes. But you see here, see the light from there comes diagonally. You see this pillar is casting a shadow. And it's fine, I'll just throw something and it will make this moody lighting. It will automatically generate. Oh, I noticed it. The platforming works. You know what I noticed? The frame froze for a moment. Is that bug with Open Lara? I have the super clipping enabled. Again, the frame, I think, or maybe not. Okay, maybe it's my button. I'm not sure. Maybe. So I made this opening to see how the light will propagate. And maybe it's a final. I'll do the platforming again. I will do the ninja move. Whee. Perfect. And now I'm up here. It's still slow. Someone asked me why is it slow. Again, the frame froze, but I don't see it in the frame rate. Oh, maybe it's the capture from OBS and not the 3DO. Am I using the super clip actually? Oh, here it might be slow. Too many individual quads with it's the cell possibly. Cause I'm rendering no, I'm rendering the ones behind. I'm rendering everything back to front, but with my polygon sorter. That's a lot of blocks with 32 by 32 textures. I cannot go inside. This is too tight. If it's one square, now my collider doesn't pass. I should make it smaller, but then I have issues. I'm going too close to the wall. So if you look here, fewer polygons are sent to the cell. But if you look from outside, even the ones that are hidden are rendered with some kind of polygon Z sorting. And this is also taxing for the cell because 2278 quads by 32 by 32 texture, and it's a 16-bit texture. Oh, cool, eh? Now let's put something like, I have two examples that might be. Let's see, those are the last two. Gritty. I like the grittiness of these old school renderers. And there is something gritty, even if it's 16-bit color and not 8-bit palletized like the VGA. There it is. Okay, now I'm on the other mode. I'm on the fly mode. A bit less polygon, 1823. I was scribbling a box again in magicavoxel, but in a way that created amazing atmospheric shadows. Again, in the magicavoxel, you just draw the voxel. You don't. It's my later processing that pre-baked the lighting. It just happened the way these voxels are having gaps and holes and random. The way they are amazing, amazing. Moody atmosphere, darker parts, shadows. You know, for example, those sides are occluded, so they get darker. Here, this side of the wall is so dark. Contrast with the outside is brighter, and the skies. This is I love when I did that and I saw how good it looked, how the shadow worked, the pre-baked shadows worked. See, the corner here are darker because here you are kind of occluded from the. This looks so good. It's just some random boxes. My polygon number is still very high. So I think the last test I did was if you make a dungeon game with very inner corridors and no outside areas to have a lot of sides, if you design a certain ways to have fewer polygons, things can be a bit better. I still have 1500, but 400. 1372. So the frame rate doesn't improve. It only improves here. So I made this little dungeon. Although the floor is. You have those little rooms. I made a solid cube and started erasing voxel to make that. I worked the or I used the invert tool. I drew some lines and some connected lines and then now here I have to do the ninja move to go up. It's very dark here. It's brighter here. And here my favorite part. Stairs. It's not much faster. Cell overhead too. Again, the opening with the pillars. I wanted to make pillars with outside sky so that I see the light propagate and make some atmospheric shadow and opening with some contrast. They do this squarey pattern, checkerboard pattern. There's a reason why. Because here, this block, if you go diagonally, it hits here. I'm doing a very good. I go diagonally, vertically, because it's easy to traverse the voxel then. If I add more direction to the calculations, not just 45 degrees, then things will accumulate better. But that's why you get the checker pattern with those pillars. And as I say, it kinda does the work. If you want some moody. Oh, that's high. And that's it, guys. This is my exciting engine, but it needs work. It needs work, but I'm getting there. It's not slow for the amount of polygons, but it can be better, or I can design things in ways that use fewer polygons. Maybe far away, I should do the opposite of subdivision for far away surfaces, but that is a bit more complex. We'll see. And that was OptiNews. And is this so good that I think I'm gonna start making a game with this one. I don't know if it's a Minecraft or a Kingsfield dungeon crawler or a combination of two. Bye!